So let us solve the R.D. Sharma binomial theorem, exercise 18.2, some selected sums. In this case, the sum number 1 is find the 11th term from the beginning and the 11th term from the end of this expression. So in this case, there are 2x minus 1 by x square whole to the power 25. So it has 26 total terms. Now we can say rth term from end equal to n plus 1 minus of r minus 1th term from beginning. From the beginning. Okay, so therefore we can say here 25 plus 1 is 26. So 26 minus of 11 minus 1. So we are getting here 16. Therefore 16th term from the beginning. So we can get T16 equal to T15 plus 1. So 25C15 2x whole to the power 25 minus 15 minus 1 by x square whole to the power 15. So we can say this 25C15 2 to the power 10 x to the power 10 minus 1 by x to the power 30. So minus 25C15 2 to the power 10 by x to the power 20. Now 11th term from beginning is T11 means T10 plus 1. So we can write this as 25C10 first term whole to the power 25 minus 10 and second term minus 1 by x square whole to the power 10. Therefore we can write this as 25C10, this is 2 to the power 15 by x to the power 15 by x to the power 20, it means x to the power 5 over. Let us go to the sum number 2. In this case, the sum number 2 is find the 7th term in the expansion of 3x minus 1 by x cube whole to the power 10. So it is easier. Second term from the 7th term, it means T7, that is T6 plus 1. So 10C6 first term whole to the power 10 minus 6 minus 1 by x cube whole to the power 6. Therefore, just if we calculate the terms, we are getting here 10C6 3 to the power 4 x to the power 8 if we separate 1 by x to the power 18, and since the even term is there whole to the power 6, so minus 1 to the power 6 is 1. So finally, just if we calculate here, we are getting 10 into 9 into 8 into 7 into 81, total 3 to the power 4 is 81 in this case, 4 into 3 into 2 into x to the power 10. So finally we are getting 17010 by x to the power 10. So this is the 7th term. Next sum. Sum number 3. Find the 5th term from the end of this expansion. So once again, rth term from the end is n plus 1 minus of r minus 1. Th term from beginning. Therefore, if we apply this concept, we are getting 10 plus 1 minus of 5 minus 1. It means 7th term from the beginning. So we can get T7 equal to 6 plus 1. So 10C6 first term whole to the power 10 minus 6 and second term whole to the power 6. It means minus 1 by x square whole to the power 6. So if we calculate here, same as this previous case, 10C6 means 10 into 9 into 8 into 7 into 81 by, in this case 3 to the power 4, that is why 81, 4 into 3 into 2 into 1, x to the power 8. So once again here 17010 total divided by x to the power 8. Then next sum. In this case, find the 8th term in the expansion. So T8 equal to T7 plus 1, that is 10C7. First term, it means x to the power 3 by 2 into y to the power half whole to the power 10 minus 7 and minus x to the power half y to the power 3 by 2 whole to the power 7. So 1 minus is coming outside, minus 10 into 9 into 8 total divided by 3 into 2 and x to the power 9 by 2 y to the power 3 by 2 x to the power 7 by 2 into y to the power, this is coming 21 by 2. So if we calculate minus 120, if we apply the indices, we are getting x to the power 8 y to the power 12. Next sum. Sum number 5 of Bhattacharya. Find the 7th term in the expansion. So T7 equal to T6 plus 1. We are getting here 8C6 first term whole to the power 8 minus 6 and second term whole to the power 6. So if we calculate, just calculation, 8C6. So 8 into 7 into 8 into 7 into 4 into 4 into 125 into 125. So divided by here 2 into 1 into 25 into 64 into x square by x to the power 6. So by calculation we are getting 4375 total divided by x to the power 4. Next sum number 6. Find the 4th term from the beginning and 4th term from the end. So once again that concept, that rth term from the end in a plus x whole to the power n is n plus 1 minus r minus 1th term from the beginning. It means here it is 9 plus 1, it means it is coming 10 minus 4 plus 1th term from the beginning. So we are getting here 7th term from the beginning. So T7 equal to T6 plus 1. We are getting 9C6 first term whole to the power 9 minus 6 2 by x whole to the power 6. And if we calculate here, we are getting 9 into 8 into 7 divided by 3 into 2 x to the power 3 64 by x to the power 6. So finally 5376 divided by x cube. And 4th term from the beginning. So normally T4 equal to T3 plus 1, that is the 9C3 first term whole to the power 9 minus 3 and second term whole to the power 3. If we calculate, we are getting 672 x cube. Next is the question number 8. Let us solve. Let us solve question number 8. In this case, find the 7th term from the end. Same problem again. So in this case, let us apply that formula, that rth term from the end in a plus x whole to the power n is n plus 1 minus of r minus 1th term from the beginning. from beginning. From the beginning. Therefore, we can say here n equal to is coming 8 and r is the 7th. So finally we are getting third term from the beginning. So third term from beginning. Third term from the beginning. So T3, that is T2 plus 1. So we are getting 8C2 2x square whole to the power 8 minus 2 and minus 3 by 2 x whole to the power 2. Now we can calculate of our own and we are getting the result. Let us go to the sum number 11. So in this case, for sum number 11, it is given expansion of 2x square minus 1 by x whole to the power 20 contain any term in of x to the power 9. Let tr plus 1 containing x to the power 9. So tr plus 1 equal to ncr first term whole to the power 20 minus r minus 1 by x whole to the power r. And if we calculate the expansion, we are getting here minus 1 to the power r 2 to the power 20 minus r 20 cr. So x to the power, if we calculate that, x to the power 40 minus 2r by x to the power r. So according to question, 40 minus x to the power 40 minus 2r minus r, that is 40 minus 3r equal to 9. It means 9 means x to the power 9. So 40 minus 3r equal to 9. Therefore, you can say r equal to 31 by 3. So number of term cannot be in fraction. It is actually not fraction, it is a non-integer. So number of term cannot be in non-integer. So there is no term containing x to the power 9. Now let's go to the question number 12. The question is, show that the x in the expansion x square plus 1 by x whole to the power 12 does not contain any term containing x to the power minus 1. Same as this previous case, let us consider tr plus 1 containing x to the power minus 1. So we are getting 12cr first term whole to the power 12 minus r, second term whole to the power r. So we are getting here 12cr x to the power 24 minus 2r minus r. So according to question, 24 minus 3r equal to minus 1. It means r equal to 25 by 3, same as this previous term. So there is no term, because r cannot be, actually r denote what? Tr plus 1 is the term. So number of term cannot be in non-integers. So there is no term containing x to the power minus 1 in this expansion. Next term, find the middle term in the expansion. So in this case, since 20 is the even number, say 20 equal to 2n. As we know, a plus x whole to the power n, n equal to even number, so n equal to 2a. Therefore m plus 1th term, otherwise directly we can say n by 2 plus 1th term is the middle term. So in this case, n equal to 10. So T11 is the middle term, and then find the coefficient of T11. Next question, find the term independent of x in the expansion of this. So we can write this as, let tr plus 1 is the term independent of x. So 9cr 3 by 2 x square whole to the power 9 minus r minus 1 by 3x whole to the power r. Therefore, we can write this as minus 1 to the power r 9cr 3 to the power 9 minus, let us write the coefficient first, then we'll accumulate all the x. 2 to the power 9 minus r into x to the power 18 minus 2r minus r. According to the question, 18 minus 3r equal to 0. So r equal to 6. Therefore, we can say T7. It means T7 is independent of x. So if the question is coming, find the coefficient. So we are getting here t6 plus 1, put r equal to 6, 9c6, 3 to the power 9 minus 12 by 2 to the power 9 minus 6. Accordingly calculate. Next the question is, if the coefficient of 2r plus 4th term and the r minus 2th term in the expansion of 1 plus x whole to the power 18 are equal, find r. So we'll apply one condition, NCR equal to NCS, then either r equal to s or r plus s equal to n. So this is a very good formula. So if n, it's the property of the NCR. If NCR equal to NCS, then either r equal to s or r plus s equal to n. Now if we apply here in this case, so 18c 2r plus 3, because 2r plus 4, that is t 2r plus 3 plus 1, so 18c 2r plus 3 equal to 18c r minus 3. So we can write 2r plus 3 equal to r minus 3 or r plus s equal to n. It means 2r plus 3 plus r minus 3 equal to 18. Therefore you can write r equal to minus 6 or r equal to 6. R equal to minus 6. Number of terms cannot be negative. So this is absurd. So r equal to 6. Here final answer is r equal to 6. So final answer r equal to 6. Let us go to the next sum. Okay, this is the question number 18. This is the question number 18. So in this question, 1 plus x whole to the power 43. If the coefficients of 2r plus 1th and r plus 2th terms are equal. So what to do? Same thing, 2r plus 1th term, coefficient of 2r plus 1th term means 43c 2r, and coefficient of r plus 2th term, it means 43c r plus 1. So NCR equal to NCS, we can write this as same thing. Once again, if NCR equal to NCS, therefore r equal to s or r plus s equal to n. Actually NCR equal to NCN minus r, this is the concept. So we can write this as either 2r equal to r plus 1 or 2r plus r plus 1 equal to 43. We can say here r equal to 1 or r equal to 14. So r equal to 1 is not possible, because if we put r equal to 1, it gives the same term. So not possible. Not possible. So r equal to, answer is the r equal to 14. Next sum, prove that the coefficient of r plus 1th term in the expansion of 1 plus x whole to the power n plus 1 is equal to the sum of the coefficients of the rth term and r plus 1th term in the expansion. So in this case, we can write this as the coefficient of r plus 1th term is n plus 1 cr, and the sum of the coefficients of rth term and r plus 1th term is NCR minus 1 plus NCR every. It is known that it is a very good property, because NCR plus NCR minus 1 equal to n plus 1 CR. This property will utilize here. It is a fundamental property, because in this case NCR plus 1 plus NCR equal to n plus 1 CR plus 1. That is, it is a true. Therefore we can write this as NCR minus 1 plus NCR equal to n plus 1 CR. This property even not needed also, we are getting this property. Okay, so in one property either this or that, so better NCR plus NCR minus 1 equal to n plus 1 CR, better we'll learn. Next question. Next question is the question number 20. Prove that the term independent of x in this expansion is 1 x plus 1 by x whole to the power 2n. So term independent of x. So we can say tr plus 1 is the term independent of x. So we are getting 2nc r, first term whole to the power 2n minus r, and 1 by x whole to the power r. According to the question, n minus 2r, 2n minus 2r equal to 0, r equal to n. So t n plus 1th term is the term independent of x, as well as it's a middle term also. So we can write this as 2n term independent of x, so no x, 2n cn. So 2n factorial by n factorial into n factorial. 2n factorial can be written as 2n into 2n minus 1 into 2n minus 2 into 2n minus 3, continuation up to 4, 3, 2, 1. Total divided by n factorial into n factorial. Now we can write this as there are n products in the numerator. There are n products. It means there are n products which are even number. There are n products which are odd number. If we accumulate the n products, 2n minus 2, 2n minus 4, continuation 6, 4, 2, and there are n products which are odd numbers, 2n minus 1 into 2n minus 3 into 2n minus 5, that is 3, 1. Total divided by n factorial, n factorial. In the n even product, if we take 2 common from each, we are getting 2 to the power n, and in this case we are getting n into n minus 1 into n minus 2, continuation 3 into 2 into 1, and in this case odd number nothing can be done, so let us keep the odd number as it is, 5 into 3 into 1. Denominator is n factorial, n factorial, so we can write this as 2 to the power n into n factorial. This product numerator is a n factorial, so n factorial, 2n minus 1, 5 into 3 into 1. Hence the proof, and sum is proved. Let us go to the next sum. This is the sum number 20. So this is the sum number 21. Sum number 21. So in this sum number 21, the coefficient of the 5th, 6th and 7th term are in AP. Find n. So 5th, 6th, 7th terms are what? In this case, 5th, 6th, 7th terms are NC4, NC5 and NC6. They are in AP. Therefore, 2 into NC5 equal to NC4 plus NC6. On dividing both sides by NC5, we are getting NC5 by NC5, it means 2. That is 2 NC4 by NC5 plus NC6 by NC5. Therefore, we can write this as 2 equal to 5 by n minus 4 plus n minus 5 by 6. If we calculate here, we are getting 12n minus 48 equal to, if we do the LCM and then cross multiply, we are getting 30 minus n square minus 9n plus 20. So we can write this as n square minus 21n plus 98 equal to 0. If we factorize, n minus 40 into n minus 7 equal to 0. So n equal to 7 or 40. Let us continue with the next sum. This is sum number 22. In this sum number 22, if the coefficient of the second, third and fourth terms in the expansion 1 plus x whole to the power n are in AP, so we have to show some condition. Let's see what can be done. In this case, second term, it means T2, that is T1 plus 1. This is coming 2nc1 in x to the power 1. If the coefficients are in AP, so we don't need the x. So T3 is 2nc2 x to the power 2, and T4 is 2nc3 x to the power 3. We need their coefficient. Therefore, we can write this as, according to the question, 2 into 2nc2 equal to 2nc1 plus 2nc3. Therefore, we can do the same thing. Let us divide numerator denominator by 2nc2. So 2 equal to 2nc1 by 2nc2 plus 2nc3 by 2nc2. Now, if we calculate once again like that previous sum, 2 equal to 2 by 2n minus 1, just calculate simply, plus 2n minus 2 by 3, cross multiply. If we cross multiply, we are getting what? 12n minus 6 equal to 6 plus 4n square minus 6n plus 2. Therefore, take everything in one side. So we are getting 2n square minus, and cancel 2, 9n plus 7 equal to 0. So this is the, yes, this is the condition. Proved. Next, let us go to the question number 23. If the coefficients of second, third and fourth term in the expansion are in AP, find the value of n on a, actually it is a similar type sum of the previous. So NC1, NC2, NC3 are in AP. So according to the calculation, same as this previous case, 2 into NC2 equal to NC1 plus NC3. Dividing both sides by NC2, 2 equal to NC1 by NC2 plus NC3 by NC2. According to the calculation, same as this previous sum, that is 2 equal to 2 by n minus 1 plus n minus 2 by 3. Cross multiply. If we cross multiply, we are getting 6n minus 6 equal to 6 plus n square plus 2 minus 3n. Therefore, n square minus 9n plus 14 equal to 0. So we are getting 9 and 14, that is 7 and 2. So n minus 2 into n minus 7 equal to 0. So n equal to 2 or 7, but n equal to 2 is absurd. N equal to 2 is absurd because in the fourth term, how will you get fourth term? So n not 2, n is 7. Therefore, final answer n equal to 7. Sum is over. Next. In this 24th sum, in the sum number 24, if in the expansion of 1 plus x whole to the power n, the coefficients of pth and qth terms are equal, and we have to prove some condition. So pth term, tp, coefficient of tp equal to tp minus 1 plus 1, that is ncp minus 1. Similarly, tq equal to tq minus, in this case, this is q minus 1 plus 1, that is ncq minus 1. Therefore, we can write this as ncp minus 1 equal to ncq minus 1. nc are equal to ncs. Then either r equal to s or r plus s equal to n. Therefore, we can write this as either p minus 1 equal to q minus 1, or we can write p minus 1 plus q minus 1 equal to n. Therefore, either p equal to q or p plus q equal to n plus 2. Okay, next sum. Next question, sum number 25. Find a if the coefficients of x square and x cube in the expansion are equal. Coefficient of x square and x cube. So it is not very hard sum. Let us expand. So 3 plus ax whole to the power 9. We are getting 9c0, 3 to the power 9 ax to the power 0 plus 9c1, 3 to the power 8 ax to the power 1 plus 9c2 3 to the power 7 ax whole square plus 9c c3 3 to the power 6 ax whole to the power 3. So we got the coefficient of x square and x cube. So according to the question, the coefficient of x square is 9c2 3 to the power 6. Since the number of terms are this is 2 and 3, but if it would have been long, suppose x to the power 10, x to the power 11, like that, so we have to just simple calculate. Okay, tr plus 1. So since it is second x square and x cube, my third term and fourth term, so we can do by expansion also. So 9c2 3 to the power 7 a square equal to 9c3 3 to the power 6 a to the power 3. Therefore a equal to 9c2 by 9c3 into 3. According to the question, we are getting 9 factorial into 3 factorial into 6 factorial into 3 total divided by 2 factorial into 7 factorial into 9 factorial. According to the calculation, we are getting 9 by 7. Sum is over. Next question. This is question number 26. This is the question number 26 of R.D. Sharma, exercise 18.2. So in this case, if the coefficient of a to the power 4 in this product, if the find the coefficient of a to the power 4 in this product. So to get a to the power 4, let us expand. Let us expand. So 1, let us expand here. So we are getting here 1 plus 2a whole to the power 4. So we are getting 1 plus 4c1 2a whole to the power 1 plus 4c2 2a whole to the power 2 plus 4c3 2a whole to the power 3 plus 4c4 2a whole to the power 4. This is one expansion into multiplied by the another expansion. For another expansion, we are getting 2 to the power 5 minus 5c1 2 to the power 4a plus 5c2 2 to the power 3a square minus 5c3 2 to the power 2a cube plus 5c4 2 to the power 3a square plus, in this case, a cube 2 to the power 3. This is a to the power 4 and this is a cube, this is a to the power 4. Just wait. Once again I am writing properly. Plus 5c2 2 to the power 3a square minus 5c3 2 to the power 2a cube plus 5c4 2 to the power 1 into a to the power 4 minus 5c5 a to the power 5. So we have to search where a to the power 4 is present. Where is the a to the power 4 present? Like if we just take 1 with 1 in the first series is multiplied with a to the power 4 in the second series. In this way, if we plus 4c1 a coefficient of a in the first series multiplied by a cube in the second series, so what we are getting? Just simple calculate. Let us calculate first the coefficient. So we are getting here 1 plus 8a plus 24a square plus 24a square plus 32a cube plus 16a to the power 4 into which is multiplied by 32 minus 80a plus 80a square minus 40a cube plus 10a to the power 4 minus a to the power 5. Now coefficient of a to the power 4, let us multiply. Let us multiply 1 with the 1 means here this is the 1 whatever I told previously, 1 with the 10, 8a, it means a with the a cube like that, and if we multiply like this we are getting the coefficient of a to the power 4, that is coming 10 minus 320 plus 1920 minus 2560 plus 512. We are getting by calculation, we are getting what? That is 1920 minus 2560 minus 320, we are getting calculation minus 438. Check the calculation once. Next question. Sum number 27 of the RT SHARMA. So in this case, if in the expansion, the three consecutive coefficients are, three consecutive terms are 220, 495, 790. Find the value of n. So in this case, we need that concept NCR by NCR minus 1 equal to n minus r plus 1 by r. It is extremely important, and let us apply. So according to the question, let the coefficients are let the terms are tr minus 1, tr plus 1. Let us consider three terms. So their coefficients are nc r minus 2, nc r minus 1, ncr. Now coefficients of these three terms are 220, 495, 792. So according to the question, we can do one thing, that nc, let us apply ncr by ncr minus 1, this concept. So ncr minus 2 by ncr minus 1 equal to 220 by 495. Now we can write this as, instead of in this example, instead of r, put r minus 1. Okay, we are getting what? We are getting r minus 1 by n minus r plus 2 equal to 4 by 9. Calculate. Let us calculate here. If we calculate here, we are getting 9r minus 9 equal to 4n minus 4r plus 8. Therefore 4n plus 17 equal to 13r. Number 1. Also ncr by ncr minus 1 equal to 792 by 495. Now in this case, we can get n minus r, this previous formula, n minus r plus 1 by r. We'll apply this. Let us apply here. We are getting n minus r plus 1. So n minus r plus 1 by r equal to 8 by 5. Therefore 5n minus 5r plus 5 equal to 8r. According to the question, we are getting 5n plus 5 equal to 13r. Therefore this is number 2. Okay, so from 1 and 2 we are getting, in the right hand side of the both are 13r. So 1 and 2 we are getting 5n plus 5 equal to 4n plus 70. So n equal to 12. Done. Answer is the n equal to 12. Now let us go to the question number 28. Under this question number 28, here the similar kind of sum is given. In the expansion of 1 plus x whole to the power n, the coefficients of the three consecutive terms are 56, 70, 56. It means two coefficients are 56. Then find n and the position of the terms of three coefficients. So we can say, suppose let rth term, r plus 1th term, r plus 2th term are the three consecutive terms. So we can write there ncr minus 1, ncr plus 1th terms. So according to the question, first term and third term is same. So ncr minus 1 equal to ncr plus 1 equal to 56. So ncr equal to ncs, so r plus s equal to n. Let us apply this concept. So r plus s equal to n. Therefore we are getting here r equal to n by 2. We got r equal to n by 2. Now we can write nc n by 2 equal to 70 and nc n by 2 minus 1 equal to 56. Let us divide. Therefore nc n by 2 minus 1 by nc n by 2 equal to 56 by 70. So we can write this as n by 2 plus 1 equal to 8 by 10. Therefore 5n equal to 4n plus 8. So n equal to 8. Therefore r equal to n by 2, r equal to 4. So terms are, therefore terms are 4th, 5th and 6th. Let us come to the next one. So it is the sum number 29. In the sum number 29, it is given if the third, fourth, fifth, sixth terms in 1 plus x whole to the power n be respectively a, b, c, d. So we have to prove some condition. So third, fourth, fifth, sixth terms. So let us calculate here. 1 plus x whole to the power n. So it is x plus a whole to the power n. There has been some printing mistake here. Here it is coming originally x plus a whole to the power n. Therefore, we can write this as third term is nc2 x to the power n minus 2 a square. Fourth term is nc3 x to the power n minus 3 a to the power 3. Fifth term is nc4 x to the power n minus 4 a to the power 4. Sixth term is nc5 x to the power n minus 5 a to the power 5 respectively. So according to the question we can write nc2 x to the power n minus 2 a square equal to a, nc3 x to the power n minus 3 a to the power 3 equal to b, nc4 x to the power n minus 4 a to the power 4 equal to c, nc5 x to the power n minus 5 a to the power 5 equal to d. Now LHS of our requirement b square minus ac divided by c square minus bd. So just put this, we'll get the requirement result and we'll get the sums easily. Okay. Next sum. Let us go to the question number 30. In this question number 30, we are seeing that similar sum if a, b, c, d in the binomial expansion of 1 plus x whole to the power n be the 6th, 7th, 8th, 9th terms, then similar type of sum. So once again, let us apply that 6th term is what? 6th term is nc5 x to the power 5, 7th term nc6 x to the power 6, 8th term nc7 x to the power 7 and 8th term, 7th term is this 6, 7, 8th term, 9th term is nc8 x to the power 8. Okay, so 6th, 7th, 8th, 9th, these are the 4 terms. These are 6th term, 7th term, 8th term, and this is the 9th term. Therefore, according to the question, let us proceed. B by A equal to, we can write this as n. It means A is nc5 x to the power 5, B is nc6 x to the power 6, C is nc7 x to the power 7, D is nc8 x to the power 8. So B by A, it means nc6 x to the power 6 divided by nc5 x to the power 5. Therefore, we can write here. Acha, let us do the next portion. And D by C equal to what? nc8 x to the power 8 divided by nc7 x to the power 7, and C by B equal to nc7 x to the power 7 by nc6 x to the power 6. Now let us divide, and we are getting here n minus 5 by 6 equal to b by a if we calculate, and n minus 6 by 7 equal to c by b. So if we divide c by b by b by a, we are getting n minus 6 by 7 divided by n minus 5 by 6 equal to c by b by b by a. If we calculate here, we are getting, 6n minus 36 by 7n minus 35 equal to c by a. So accordingly, if we proceed, b square minus ac by c square minus bd like previous, we will get our requirement result. Next question is 31. Question number 31. If the coefficients of the three consecutive terms in the expansion 1 plus x whole to the power n be 76, 95 and 76, so we are getting the, we have to find the value of n. How to find the value of n? Same as this previous. Let r plus 1th term, r plus 2th terms are consecutive terms in the expansion. So their coefficients are NCR minus 1, NCR, NCR plus 1. So according to question, we are getting NCR minus 1 equal to NCR plus 1. Therefore, we can write r minus 1 plus NCR equal to NCS. So r plus s equal to n. That formula will apply, equal to n. So r equal to n by 2. Now NCR by NCR minus 1 equal to 95 by 76. So NCR by NCR minus 1, that formula, n minus r plus 1 by r. Therefore n minus r plus 1 by r equal to 95 by 76. Therefore instead of r, we can put the value of n. We are getting n by 2 plus 1 by n by 2 equal to 95 by 76. So we can write, if we cross multiply, we are getting 38n plus 76 equal to 95n by 2. Therefore 19n by 2 equal to 76, n equal to 8. So we got n equal to 8. Next question. Question number 32. If the 6th, 7th and 8th term in the expansion of x plus a whole to the power n are 112, and in this case what, 7 and 1/4, find x, a and n. So what can be done here? We can get the result easily. So same as this previous case, let 6th term, 7th term, 8th term. 6th term is NC5, x to the power n minus 5, a to the power 5. 7th term NC6, x to the power n minus 6, a to the power 6. And 8th term NC7, x to the power n minus 7 and a to the power 7. Now let us calculate according to the values. It means we are getting NC5, x to the power n minus 5, a to the power 5 is 112, and NC6, x to the power n minus 6, a to the power 6 is 7, NC8, x to the power, not 8, N7, NC7, x to the power n minus 7, a to the power 7 equal to 1/4. So if we divide first and second, we are getting some values. If we divide first and second, we are getting NC6, x to the power n minus 6, a to the power 6 divided by NC5, x to the power n minus 5, a to the power 5 equal to 7 by 112. From this we are getting From this we are getting n minus 6 plus 1 total divided by 6 into a by x equal to 1 by 16. Therefore, a by x equal to, we are getting what? 3 by 8n minus 40. Also similarly, we are getting, if we divide third by 2, we are getting some another relation. So again, if we apply nc7 x to the power n minus 7 a to the power 7 divided by nc6 x to the power n minus 6 a to the power 6 equal to 1/4 by 7. If we apply the condition, we are getting n minus 7 plus 1 by 7 a by x, we are getting 1 by 28. Therefore, a by x equal to 1 by 4n minus 24. So this is number 1, this is number 2. If we equate the number 1 and number 2, we are getting 3 by 8n minus 40 equal to 1 by 4n minus 24. Therefore, we are getting here, if we multiply, we are getting n equal to 8, and accordingly we will get the value of a and x. Let us come to the question number 33. In this 33, it has been given that if second, third and fourth term of this expansion are 240, 720, 1080, we have to get the value of, similar like the previous sum, we have to get the value of x, a and n. So let us do same thing. Second term is what? nc1. So according to the question, directly I am writing nc1 x to the power n minus 1 a to the power 1 is 240, and nc2 x to the power n minus 2 a squared is 720, nc3 x to the power n minus 3 a to the power 3 is 1080. So if we divide 720 by 240, it means we are getting here nc2 x to the power n minus 2 a to the power 2 by nc1 x to the power n minus 1 a equal to 720 by 240. Therefore, n minus 1 by 2x into a equal to, we are getting to be 3. Therefore, a by x equal to 6 by n minus 1. It is number 1. We got it to be number 1. Now for the number 2, for the second case, we are getting also we are getting same thing, divide by 1080 by 720. So nc3 x to the power n minus 3 a to the power 3 by nc2 x to the power n minus 2 a to the power 2 equal to 1080 by 720. And in this case, we are getting n minus 2 by a by 3x equal to 3 by 2. So a by x equal to 9 by 2n minus 4 is the number 2. Equating 1 and 2. Equating 1 and 2, we are getting 6 by n minus 1 equal to 9 by 2n minus 4. So multiply 2n minus 4. So multiply 3 and 2. So 2 into 2n minus 4 equal to 3 into n minus 1. So accordingly we are getting n equal to 5. After putting n equal to 5 in number 1 equation, n equal to 5 in number 1 equation, 6 by n minus 1, this is n, in number 1 equation. So we are getting 2a equal to 3x. In number 1 equation, in this case, no, it is coming a by x equal to 8. This is n. Okay. So now 5c1 into x to the power 5 minus 1, that 243 by 2 into 3 by 2x equal to 240. So 15x to the power 5 equal to 480. Therefore x to the power 5 equal to 32. So x equal to 2. So by putting n and x in any one, either 1 or 2, we are getting a equal to 3 over. Let us come to the question number 34. In this question number 34, it has been given, find a, b and n in the expansion a plus b whole to the power n, and if the first three terms of the expansion are same as the previous sum, 729, 7290 and 30375. This is some calculative sum. Therefore, a, b, n, first three terms, first term, second term, third term. So first term is, let us calculate like this: a to the power n equal to 729, and second term nc1 a to the power n minus 1 and b to the power 1 is 7290, and third term nc2 a to the power n minus 2 b to the power 2 is 30375. Let us divide the 3 by 2, third equation by second equation. We are getting nc2 a to the power n minus 2 b to the power 2 divided by nc1 a to the power n minus 1 b. We are getting here 30375. This is sum, not calculative sum, and this is coming 7290. If we divide, we are getting, here it is n minus 1 by 2 b by a. I have already calculated in calculator. So 25 by 6 it is coming. So n minus 1 into b by a equal to 25 by 3. And if we divide second equation by first equation, it means 7290 by 729. 7290 by 729, it will be something easier for us to calculate because they are getting directly calculated, cancelled. nc1 a to the power n minus 1b divided by nc0 a to the power n. So in this case, nb by a equal to 10. So let us give as the equation number 1, and we are giving this as the equation number 2. So let us make 2 divided by 1. We are getting here nb by a divided by n minus 1b by a equal to 10 into 3 by 25. From this b by a is getting cancelled, so n by n minus 1 equal to 6 by 5. Accordingly, n equal to 6 we got. Since a to the power 6 is 3 to the power 6, therefore a equal to 3. Okay. Now nb by a equal to 10. So put n as 6 and a is 3. We are getting b equal to 5. In this sum, if the term free from x in the expansion of root x minus k by x square whole to the power 10 is 405, find the value of k. So in this case, we can write this as, let tr plus 1 equal to 10 cr first term whole to the power 10 minus r minus k by x square whole to the power r. So this can be written as 10 cr x to the power 5 minus r by 2 minus 2r minus k whole to the power r. Now according to the question, 5 minus 5 by 2 r equal to 0. Therefore r equal to 2. So third term T3, so T3 is the term which is independent of x. Therefore T3 equal to 10c2 into k square equal to, according to the question, it is 405. Therefore 10 into 9 by 2 into k square equal to 405. So we can say here k square equal to 405 into 2 by 10 into 9. That is coming to be 9. Therefore k equal to plus minus 3. Let us go to the next sum. This is the question number 36, and in this question number 36 it is given that find the sixth term in the expansion of y to the power half plus x to the power 1/3 whole to the power n if the binomial coefficient of the third term from the end is 45. So third term from the end in the expansion is nc2 because terms are equidistant. Therefore nc2 equal to 45. Therefore n into n minus 1 by 2 equal to 45. Therefore n square minus n minus 90 equal to 0. So n minus 10 into n plus 9 equal to 0. So n equal to 10 because n cannot be 9. The reason is that number of term cannot be negative. So we can say here n equal to 10. Let T6 be the sixth term in the binomial expansion of p by 2 plus, in this case we are getting to be not p by 2, this is coming what, y to the power half plus x to the power 1/3 whole to the power 10. So T6 here is nc5 y to the power half whole to the power n minus 5 into x to the power 1/3 whole to the power 5. Therefore n equal to 10 here. We can write this as 10c5 y to the power 5 minus 5 by 2, that is 5 by 2 into x to the power 5 by 3. 10c5, if we calculate, we are getting 252 into y to the power 5 by 2 into x to the power 5 by 3. So another two sums are there left in this chapter. So students, you can solve this because this is the another chapter, another sum which has been given here. If p is a real number and if the middle term of the expansion is 1, 1, 2, 0. So what can be done here? So let us do this is solved also this sum. So in this case it has been given that fifth term, because whole to the power 8, so 8 by 2 plus 1/8 term equal to fifth term is the middle term. Therefore T5 according to the question 1, 1, 2, 0. Therefore we can write 8c4 into p by 2 whole to the power 8 minus 4 into 2 to the power 4 is 1, 1, 2, 0. So we can write this as, if we calculate, p to the power 4 equal to 16. So p equal to plus minus 2. Just another two sums are left. So you can solve these two sums. Okay, everybody. And I'll give lot of such sums in R.D. Sharma solution in this way, chapter by chapter. So follow the videos.